Hi everybody, my name is Mrs. Shiro. I teach chemistry here at Ranch View High School. I'm here today to talk to you about some introduction to chemistry that we're going to start this year so you are ready to go for next year. So as you can see, we are going to be talking about phase changes and states of matter. And by that I mean solids, liquids, and gases. For this, we are going to be referring to solids as having particles that are very close together, liquids, which have particles that are a little bit farther apart, and gases, which have particles which are very far apart. For this particular slide, I would like you to get out a sheet of notebook paper and go ahead and draw yourself a 3-column sheet of notebook paper so you can take some notes. If you need to pause this video at this time so that you can record this as properties of solids, liquids, and gases, please go ahead. You will want to draw the pictures at the top as well as the words across the top and the words down the side. When you are done, please click play again so that we can talk about what fits inside each column. Okay, so when we are talking about shapes of each of these states of matter, solids have very defined shapes. Liquids have a less defined shape. In other words, it takes the shape of the container, so it can be any shape. And gases do the same. Remember, at any time, if I'm going too fast, you can stop your video so you can take some notes. Let's talk about volume of the different states. Solids have a very definite volume and they do not usually change their volume. Liquids have also a definite volume which can be somewhat changed by heat, but for the most part the volume stays the same. And gases very definitely take up the different size of the container that it's in. So it can take up a big container or it can be compressed into a smaller container. How about that arrangement of particles? Once again, we're talking about solids having particles which are very close together, liquids having a little bit more random orientation of their particles, and gases have very random particles which are far apart and do not follow any set structure. What about movement? Solids have particles which vibrate while they are stuck in place, and we say this has low kinetic energy. Liquids have particles which can loosely move past each other, and we say they have greater kinetic energy. And gases have particles that have the most kinetic energy and particles that have free movement past each other. Our next and final type of property is called compressibility. And so we can compare compressibility as how well is it able to be squeezed. Solids are not easily compressible, as are liquids. Neither one of these two really can be squeezed into a smaller container. However, gases do have the property of being compressible. In other words, we could compress a gas into a smaller container, or we could expand the gas to fit a larger container. Remember, at this time, if you need to pause so that you can take all the notes, please go ahead. When we are talking about states of matter and how states of matter change from one state to another, it is really all about how much energy has been absorbed or released. So remember that the difference we basically have is that solids particles are very close together, liquid particles are further apart, and gaseous particles are the farthest apart. If we are talking about how much energy, solid would have to absorb some energy to become a liquid, and liquid would have to absorb some energy to become a gas. The opposite happens if we want to change from a gas, releasing energy to condense to a liquid, releasing still more energy to freeze into a solid. So that means that there is some terminology that we have got to know. So I would, at this time, if I were you, pause this video so that you can draw your diagram of what does each of these changes look like. I'm going to continue talking. If you need to pause at any time, please go for it. So if we change from a gas to a liquid, you know that is called condensation. If we do the opposite, liquid to gas, you know that is called evaporation. If we have a liquid and we change it to a solid, you know that terminology as freezing, but sometimes you will also hear that called solidification or crystallization. The opposite is when a solid changes into a liquid, and we still call that melting. The two new terms that you might not have heard before are sublimation and deposition. Sublimation is for when a solid changes into a gas, and you might have seen that before in the form of dry ice. When dry ice is taken out of the freezer, it immediately begins to sublimate and form a fog or a gas from the solid. Deposition is when a gas changes into a solid, and if you've ever seen snow, then you have seen deposition. This is when water vapor in the air solidifies into snowflakes and begins to fall from the sky. Remember, please, if you need to pause this video so you can draw your diagram into your notes, please do so. All right, so at this time, we're going to take some time to practice with this, and we're going to take a look at what is called a heating curve. This is a heating curve. You'll notice that A at the bottom is where the solids are found, and C right in the middle is where liquids are found, and gases right at the top are where, E is where gases are found. And you'll notice by looking at the axes that the temperature is increasing on the y-axis and the energy is increasing on the x-axis. So let's see if we can answer some sample questions. So we want to know what phase change is taking place at B when you move to the right. Remember, phase changes are things like condensation, evaporation. So what is happening at B as you move to the right? In other words, as you move towards greater energy. Okay? If you said that the solid must be melting, then you are right. If we make a solid absorb energy, it is going to begin melting. And let's look at number 2. What phase change takes place at B when you move to the left? Well, at B, if you move to the left, we are talking about a reduction in energy. In other words, we are making B, whatever that matter is, release energy. And so what is taking place is we are starting to see some freezing. Okay, let's try one more. Let's take a look at what is happening in terms of temperature and energy in area C. And I want you to look at area C as we move to the right. What is happening to temperature and energy as we move to the right? You might notice that this part of the heating curve is a straight line in the upward direction. That means it has a positive slope. That means both temperature and energy are increasing. At this time, you will probably have some questions to answer. I hope you have enjoyed this video.